So let's just revisit the exponent properties to make sure that we're on the same page here. So you want to use the exponent properties. You don't want to expand, okay? We don't want to expand, and I noticed on some of the homeworks, students were expanding based on what we did in the investigation. The investigation was just to refresh our memory on the exponent rules. So in number 1, if I have -2 to the -4, this means I take 1 over, the -2 is in a parenthesis. Now, you take -2 times -2, which is 4, and then 4 times -2 is -8. -8 times -2 is 16. In number 2, there's no parenthesis, so this means 3 times n to the -2, and that'll be 3 times 1 over n squared. Now that 3 is 3 over 1, so that's 3 over n squared. Feel free to pause the video at any time if you need to stop and think. So if I have -2x, the quantity cubed, this is -2 being cubed and the x being cubed. That's our exponent property. -2 when I cube it is -8 x cubed. Number 4, if I have 3 n to the 6th, all to the 4th power, I'm going to take 3 to the 4th, and I'm going to take n to the 6th to the 4th. Well, remember we talked yesterday, 3 to the 4th is 3 squared times 3 squared, 9 times 9, that's 81. N to the 6th to the 4th is n to the 24. And the reason why you don't want to expand is I really don't want to write out 24 n's. Like would be terrible. Number 5, I wanted to do this one on purpose because if I take 2/3 to a negative exponent, some of you were doing 1 over 2/3. And there's nothing wrong with that, but you can't leave a fraction within a fraction. So there's a faster way to do these. If I have a fraction to a negative exponent, and we did this when we were graphing, you flip the fraction, you take the reciprocal to the positive 4th. So that's 3 to the 4th over 2 to the 4th. That's 81 over 16. In number 6, if I have a negative exponent, I can flip it, take the reciprocal, and cube it. So 5 to the 3rd over x squared to the 3rd. So that's 125 over x to the 6th. What's interesting about exponent properties is that there's oftentimes more than one way to do them. And as long as you're getting to the same final answer, it's okay. All right, so I'm going to deal here in the numerator. Do you see I have d to the 5th times d to the 2nd? So that's d to the 7th. That's the only thing I'm doing right now. I handled d to the 5th times d to the 2nd. Now, 12 divided by 3 is 4. I just have the lonely d to the 7th. And then this exponent on f is implied to be a 1. So that's 1 minus -2. So that's 4d to the 7th, f to the 3rd. All right, number 8, this was on the practice quiz, and this was the most missed problem. It really wasn't that many people, but I thought it was worth talking about. So you're going to subtract the exponents. So that's m to the -6 minus -13 times n to the -3 minus a -1. So that's m -6 plus 13, n to the -3 plus 2. That's m to the 7th. Oh, sorry, I just caught my little mistake there. I was thinking of my answer. Minus a -1 is plus 1, so that's -2. So that's m to the 7 times 1 over n squared. M to the 7 is like m to the 7 over 1. All right, number 9. Again, there's more than one way to do these. I personally, if there's things that I can reduce, 28 and 8 have 4 in common. So I'm going to make that a 7 and a 2. And then if I subtract 5 minus a negative 3, that's y to the 8th. Then you're going to take 7 and cube it. You're going to take y to the 8th and cube it, and take 2 and cube it. All right, so then you're going to do 7 cubed is 343. This is y to the 24, because you have to multiply. And then that's my final answer. So I hope this helps from what we did yesterday.